Ready?
Go.
All right, we just took a quiz on the board, so if I give you a 0, it won't be a whole lot different than what they got, so they didn't do too well. The quiz worked like this. We numbered from 1 to 10, and the answers were A, B, C, D, or E, 5 selections, and then they had to guess each one. So they just randomly guessed the answers, then I read the answer key, and everyone got one right. So we're going to talk about this and see if it's a binomial random variable, where we have x equals the number correct. All right, so we said it passed the binary test, and MD, what about independent? Is one answer related to the answer before it? No, they're not. All right. So what about the number? Is the number? What's N stand for?
Number of trials.
Right. Is it set? It is. There were 10 trials, and S was the funny one to remember. Do you remember it yet?
Yeah.
Equal probability.
It's the same probability. S for same. Same probability.
Oh, did we do that yesterday?
No.
Oh, that's genius. All right. All right, go back to your notes and add that same probability. I love it. We had a really complex expression. We said
Success is equally probable for each trial.
Why did we
I
just say
came up
that?
with that one.
Same probability.
Yesterday you were doing so nice.
All right. Let's go back and strike that from the notes. And
Okay.
put in S, same probability for each trial.
It's not a difference.
All right, very good. All right, so did you have the same probability for each one to get it correct? Did you?
Yes.
Yes, you did. All right, so it is a binomial random variable. It passed the Bin's test. So now I want to know, what is the probability that someone would get 3 right? All right, since it's binomial, we can set that up with a formula we learned yesterday. And the formula went like this. We did a counter where we had a number of combinations, then we had a probability, and it was raised to something. And then we had the opposite probability raised to something. What? This was K?
Yeah.
This was N minus K.
Yep.
All right, so can you use that from yesterday? That's called the binomial theorem, and we're going to figure out what it would be to have exactly 3 correct on this game. So, MD, what would these values be? N and K.
It would be N would be 10, and then K would be 3.
Right. All right. So, what's the probability, of getting one correct? All right, so that's 0.2, and we're going to raise that to K, which is identical to that number. And then MK, what do I put as 1 minus P?
1 minus 0.2.
1 minus 0.2,
0.8.
which is?
0.8.
All right, and we raise that to what, MK?
To 7.
Right. Okay. Do you remember how to get 10 over 3 out of your calculator? Go ahead. You're going to have to hit the 10 first. Then you go to your math menu, probability, and hit NCR. And then you would hit 3. So that'll get you that number. It's probably a big number. I mean, wouldn't want to write them all out. It's not that huge, but what is it?
120.
Anyone confirm that 10.3 is 120? It is? Okay. So we got 120 here. We'll trust them. And then 0.2 raised to the 3 and 0.8 raised to the 7 multiplied all together. Do you have a probability for that?
.201.
0.201 or 20% basically. Anyone confirm?
Mm-hmm.
All right, so that is, from looking at your work, 20% of course it's low in that 100%. From 100% to 20% is quite a drop, but it is a possibility. It's like 1 in 5 chance of getting 3 right, yet we only got 1. So, kind of interesting. So, just curious about that. Let's see what the probability of getting 1 right is. It's probably pretty high. So go ahead and do the same. This is your probability, what you did. Let's do it on the calculator just for practice. So you're going to go, you don't have to do any of this if you go on the calculator. You can go to second bars, and you don't go to the normal probability. You ignore the first 2 selections to go all the way down to binomial. And this one is PDF. And it asks you for some selections, and I'm not sure I remember what goes in those selections. Anyone? Does anyone have the questions?
It's trials.
Trials. So on this one, we're going to put 10. Then what's the next question?
Probability.
Probability of a success was 0.2. And what's the number?
X
And we
value.
want 1. So can you tease that out of your calculator? Then we don't have to do it by hand. All right. What did everyone else get?
0.268.
All right. So it's still 0.26. So 26% chance of getting 1 right. Okay. I thought it'd even be higher than that. You'd think we'd guess 1 right out of 10 more often than that. All right. But that's what it is. Alright, so before we leave this concept, this is review, so nothing really new yet. The only thing I want to tag on to it to make my final statement on this day notes. Yay, we have some tissues. I need to grab some for my next class. Remind me. Let me discuss the probability of having, say we want to, instead of the probability of x equals 3 and x equals 1, what's the probability of getting, say, 7 or more correct in this game? So, can you think of how we would set that up with either our calculators or by hand? What do you think we would have to do? MK, any thoughts? Greater than or equal to 7 would include what results?
7, 8, 9.
Alright, so we would have to do the probability of 7 plus the probability of 8 plus the probability of 9 plus the probability of 10, and that would give us the correct answer. Can anyone think of a shorter way of doing that? Because we have to do one of these either by calculator or one of these by hand for each of these and add them up. It's not impossible, but is there a little bit quicker way to do it? That's what I want to present now. So this is the same as 1 minus the probability of what? MD, what would be sort of the opposite of this?
Probability of 6.
All right, 6 or below.
Right.
Is that right? So I'm going to say the probability that x is less than or equal to 6. Do you see that this is the complement of that? So we can say 1 minus this. So why is this easier? Because you can do, if you did the probability less than or equal to 6, you got to do 6, 5, 4, 3, 2, 1, and 0. Because your calculator does less thans under this command. So you'd have to plug in 1 minus, then you'd go back to binomial, but instead of PDF, actually I looked up that PDF, and that PDF meant probability, which doesn't really help us remember what it does. Probability density function is what PDF stands for, and I was hoping the name would help us remember that it's only at 1 point. So in fact, last year they said, well, P for 1 point. So I don't know if that helps you or not. But here, instead of a PDF, we're not caring about 1 point. The calculator will do everything less than, under this command, it will do everything less than if you use CDF. So CDF is, it wasn't continuous. What word was it? What was it? I think I wrote it down. Cumulative. So that means cumulative density function. So that means you have more than one when you have a cumulative effect. So your calculator will do the whole thing for you. You're going to have to hit the 1 minus before you go to your binomial button, then CDF, and then you're going to put in 10 trials and probability of 0.2, and you're going to give it 6. And when you give it the 6, it knows, because it's a CDF command, to do everything less than 6. Just remember, the calculator is always doing less than this number. Because sometimes you might want more than, and you'll have to mess with the 1. In this case, we don't have to. Well, yeah, we want it more than 7, right? So we are doing 1 minus this less than. All right, tap away, see what you get. I have the answer. It's pretty low. Anyone get one?
Yeah. I got 0.0009.
Whoa. 0.0009. I didn't get that.
I got 0.0000.
0? That's it?
Wait. 1, 2, 3, 0.
Alright,
There's
that's
4
what I got.
zeros, and then it's 8, 6.
I didn't get that.
That's the same thing that I got.
Oh.
I just did it like.
Oh, you rounded it. Okay. What's wrong with me then?
I don't know.
And Martin got the same thing.
No, there's only 3
All
zeros.
right. I must have tapped it in wrong. It's still small, so I'll go ahead and agree. So
It's 3 zeros. It's not
it's
4.
3 zeros.
Yes, I messed up.
All right. So therefore, to make it a percentage, we get 0.086%. So the chances of getting these high numbers is very, very, very slim. Which, are you surprised? When you did it, you only got 1. Wouldn't we be surprised if any of us got 6, 7, 8, or 9 or 10? I'd be surprised if you got 2. So, all right. So it is a very small probability. But what I wanted to do is use this example to teach this concept and this part on the calculator. So if you were doing the probability, now we're not going to do it, but if you were asked to do the probability that x was greater than 8, what would be the way to do it using a CDF? So how could you set that up?
You would do 1 minus
Right. The probability of what?
x is less than 7.
Right. All right. So that's what I'm teaching you today. How you can get this out of that, and this is easier on your calculator. All right. Any questions on how to use that command and when to use
So,
it?
is there a difference between, because like that one is just greater than, but, so would you include 8?
You're right. You're right. So this one, because it's greater than 7, you would include 8. You're right. Very good. All right. So probably I meant to say greater than, but the way I did it, it does make a difference. So thank you. All right. That's the end of that day's work. Any questions on the homework? I can take that up.
It's right here. We're good.
I already did. Okay. Did I give you yours?
Yeah,
Yeah.
that's
You are?
right.
I'm ahead of myself. All right. Good. All right, day 6 then. Day 6. I think there's only 7 days and then a couple reviews. So, oops. So what will that day was? What's a good day for testing? Today is Wednesday, so say we finish up the information tomorrow, between today and tomorrow. What's that? And then Friday, we could start reviewing. Friday, Monday, review. Test Tuesday. What's your Tuesday look
We
like?
have a apologetics quiz, but
Does that make a big difference?
not really. I'm okay.
I could do Wednesday.
It's okay. I think
We could do
I'll be
Tuesday
fine.
because then, like, we could actually like start the next chapter and like get a decent way through because then we'll have
Week
5
and a
school
half.
days to do it instead of
Yeah.
having like
2. Like, all right, let's shut this section